Hello everyone. In this video, I will be discussing learning objective 2 of this week, interpreting a correlation matrix. So basically, we will be talking about correlation matrix and the statistical significance of correlation coefficient. In the last video, we learned about correlation coefficient, and we said that correlation coefficient is basically measures the strength of degree of relationship between two variables. So, and correlation coefficient ranges between -1 to +1. So if correlation coefficient between two variables is, let's say, 0.9, it indicates a strong positive correlation between two variables. Now, what correlation matrix is? Correlation is a bivariate analysis. So when we find out a correlation coefficient, that's the relationship between two variables. Now, if we have multiple variables, we can calculate correlation coefficient for each pair of variables. For example, if we have three variables, x, y, and z, we can calculate correlation for x and y, y and z, z and x, like this. And correlation matrix is a standard way of reporting correlation coefficient for this each pair of variables. Now, you understand that if you have 10 variables and you calculate correlation coefficient for each pair of variables, you will have number of correlation coefficient. And a standard way of representing this correlation coefficient is correlation matrix. This is how we calculate correlation coefficient. We also discussed it in the last video. I'm not discussing this in detail because we do not go for this manual calculation of correlation coefficient anymore. Rather, we calculate correlation coefficient using Excel spreadsheet or other softwares. Now look at this correlation matrix. If you look at these numbers, these are the correlation coefficient between two variables. For example, this one is the correlation between performance, and here is performance as well. That's why it is 1. So in this case, a research was conducted to see the correlation coefficient between some factors. For example, performance of an employee, job satisfaction of an employee, generalized self-esteem, specific self-esteem, other directedness, verbal intelligence, job-related tension, role ambiguity, tertiary potential, and workload. These are some factors that actually contribute to job performance or job satisfaction. Now we calculate correlation coefficient between each of two variables and report them in this standardized table that is correlation matrix. Now if you pick up any one, for example, 0.61, 0.24, 0.26, 0.38, all these indicates correlation. And since these numbers are positive, that means they are a positive correlation between these two pair of variables. For example, job-related tension and other directedness is a positive correlation, and correlation coefficient is 0.26. Now we can see that some numbers are negative. For example, -48, -27, -0.27, -0.38. So it indicates that there is a negative correlation between this pair of variables. For example, job-related tension and job performance, there is a strong negative relationship. It's 0.48. So it's a negative relationship. This is correlation matrix. So once again, this correlation coefficient indicates a strength of relationship, and the sign of the correlation coefficient indicates the direction of relationship, if it is positive or negative. Now you can see some small letters like B, C. What is this? In the last slide or the slide before, we had statistical significance. Now, as I mentioned, that correlation coefficient ranges between -1 to +1. So larger correlation coefficient indicates a stronger relationship, and smaller correlation coefficient indicates weaker relationship. For example, if a correlation coefficient is 0.1 and correlation coefficient is 0.9, that of the 0.9 correlation coefficient definitely indicates a stronger correlation compared to 0.1. Now the question is, how do we understand if this correlation coefficient is statistically significant or not? In this case, we'll also perform a t-test that we learned in the last class, and we test a null hypothesis that if the correlation coefficient is equal to 0 or not. Can you remember in the last lecture we have seen the null hypothesis, for example, x is equal to y, or a certain variable is equal to a benchmark. So in this case, we also test a null hypothesis that correlation coefficient is equal to 0. Now, you understand that correlation coefficient equal to 0, if you accept this null hypothesis, it means that there is no correlation because correlation coefficient equal to 0. And if you reject this null hypothesis, that means correlation coefficient is significantly different from 0, so there is a significant correlation. Now, if you look at these numbers B and C, so on, they actually indicate statistical significance. For example, when it is B, this correlation coefficient is statistically significant at 1% level. So these are statistically significant correlation. And C indicates the statistical significance. So the previous one was 0.1%, this one is 1%. C is statistically significant when the correlation is statistically significant at 1% level. So when we run a correlation, we get the correlation coefficient. At the same time, we get a t-statistic and p-value that indicates that whether the correlation coefficient is significant or not. Look at here, this is another example. These are the factors that makes a person attractive. For example, feet attractiveness, fat, age, modern, and cold. So correlation coefficient is calculated for these variables. For example, these one attract and feet 0.831. Fat and fit, this is minus 0.267. So once again, this positive correlation coefficient indicates a positive relationship and negative indicates a negative relationship. And you can see we got, with each correlation coefficient, we got a p-value. So when p-value is less than the significance level, it indicates that your null hypothesis was rejected. What was the null hypothesis? That correlation coefficient equals to 0. For example, here your p-value is 0. It means you reject your null hypothesis that correlation coefficient equals to 0. It means that you accept your alternate hypothesis that your correlation coefficient is different from 0 or significantly different from 0. So this correlation coefficient is statistically significant. So is this one, this one, this one, and this one also. For example, here your p-value is 0.65, so it's greater than the significance level. That means we accept the null hypothesis that correlation coefficient is equal to 0. So this correlation coefficient is not statistically significant. I think you understand the correlation coefficient and correlation matrix. We will be discussing regression analysis in the next video. Thank you.